Hi all. Today we are going to see about A star search algorithm. A star search algorithm is an informed search algorithm. What is informed search algorithm? It is the heuristic algorithm. They have the problem definitions and path cost value to achieve the goal state from the initial state. A star search uses heuristic function h of n and cost to reach the node n from the start state g of n. It has combined features of uniform cost search and greedy best first search algorithms by which it solves the problem efficiently. What is uniform cost search? It is to find the path to the goal node which has the lowest cumulative cost. What is best first search? Best first search algorithm always selects the path which appears best at that moment based on the heuristic value. A-star search algorithm expands less search tree and provides optimal result faster. A-star algorithm is similar to uniform cost search except that it uses the evaluation function g of n plus h of n instead of g of n. In A-star search algorithm, we use search heuristic as well as the cost to reach the node. Hence, we can combine both costs as following, and this sum is called as the evaluation function, that is E of n is equal to g of n plus h of n, where E of n is the estimated cost or the evaluated cost and g of n is the path cost from the start node and h of n is the heuristic value for each and every node. Next, we can see the algorithm of A-star search algorithm. Step 1. Place the root node in the open list. Step 2. Check if the open list is empty or not. If the list is empty, then return failure or error and then stop. Step 3. Select the node from the open list which has the smallest value of the evaluation function E of n, and if node n is the goal node, then return success and stop. Else, step 4. Expand node n and generate all of its successors and put n into the closed list. For each successor n, check whether n is already in the open or closed list. If not, then compute the evaluation function for n and place it into the open list. Step 5. Else, if node n is already in open and closed list, then it should be attached to the back pointer which reflects the lowest g of n value. Step 6. Return to step 2. Next, we can see one example for A-star search algorithm. So, this is the given graph and this is the heuristic value given for each and every node in the graph. And here, two lists have to be maintained. They are named as open list and closed list. Open list contains the nodes which are not yet expanded, and closed list contains the nodes which are expanded already. Next, we can see the solution steps one by one. Place the initial node into the open list. In the given graph, the initial node is S. So, place S in the open list. Remove the node S from the open list and place it into the closed list. Next, find the adjacent nodes of S and place those nodes in the open list. The adjacent nodes of S are here Q and R. Find the heuristic values of nodes Q and R. So the heuristic value of nodes Q and R are 11 and 5. Add these heuristic values to the cost value of the nodes to reach from the initial node S. That is, for Q, the heuristic value is 11 and the path cost value for this node to reach from S is 1. Add 1 to the heuristic value 11. So you will get 12. That is 11 plus 1 which is equal to 12. Next, for R, the heuristic value is 5 and the path cost value to reach R from the initial node S is 2. So add 5 plus 2 which is equal to 7. Now place these nodes Q and R along with the evaluation cost. Q is equal to 12 and R is equal to 7. Now R is having the minimum value when compared to the node Q. So move the node R from the open list to the closed list. Next, find the adjacent nodes of R. The adjacent nodes of R are V and W. Find the heuristic values of nodes V and W. The heuristic values of V and W are 9 and 3. Next, find the cost values for the nodes V and W from the root node S. For V, the path cost value is 2 plus 3, which is equal to 5. And for W, the path cost value from S is 2 plus 2, which is equal to 4. Add these path cost values with the heuristic value. So, for node V, we will get the value as 9 plus 5, which is equal to 14, which is the evaluation cost. For node W, the heuristic value is 3 and the path cost value we have obtained is 4. So 3 plus 4, which is equal to 7, which is the evaluation function for node W. Now, place these nodes V and W in the open list along with the evaluation cost. Now, W is having the minimum value when compared with the node V. Hence, move W from the open list to the closed list. Next, find the nodes which are adjacent to W. In the given graph, the adjacent node for W is G. Place node G in the open list along with the evaluation cost. That is, the heuristic value for node G is 0 and the path cost value for node G from the node S is 2 plus 2 plus 2, which is equal to 6. So the evaluation value is 0 plus 6, which is equal to 6. Place node G along with the evaluation cost in the open list. Now move node G from the open list to the closed list. Since G is the goal state, the searching process can be stopped at this point. The closed list will give you the optimal path for the given graph from the initial state S to the goal state G. Hence, the final optimal path to reach from S to G is S or W G. Thank you.